Hi, Dr. Ryman back again with you to talk about two-dimensional arrays. So where we left off with part one is that we just had finished up this transpose and we were about to do subarray. And so let's do that. So basically the idea of a subarray is I'm going to copy a block of elements out of this two-dimensional array from row I1 to I2 and columns J1 to J2. And I'm going to include the endpoints there. So the first thing I need to do is figure out, well, how many rows do I have? I want to start at I1, I want to end at I2, and so imagine if I was going from 1 to 10, the number of elements that I have in there is going to be 10. I can get that by taking the upper bound and subtracting off the lower bound, but I need to add 1 back in there. So just like 1 to 10 is going to be 10 minus 1, which is 9, plus 1. I'm going to have I2 minus I1 plus 1. So let's do that. I2 minus I1 plus 1. That's going to be the number of rows. The number of columns is going to be J2 minus J1 plus 1. That's going to be the number of rows. Or number of columns, excuse me. So I want to create a new array. So let's call that new array B. And that's going to be this big. Okay, now that we have this B array, what we're going to need to do is fill that. So and I think it's easier in this case, as we've done in the past, is to think about from the B array perspective, for each ij element in that B array, where did that have to come from? So I'm going to loop over every element in B. For int I is assigned 0, I is less than B dot length, B plus plus, how about J plus plus, I plus plus maybe, and then for int J is assigned 0, J is less than B sub I dot length, J plus plus, and then now inside this J loop, this is where we're going to do all that copying. Now, I want to start at B sub I sub J, but where's that coming from in the A array? Well, note that when I is 0, I want to pull from I1. When I is 2, it's going to be I1 plus 1 and so on. So really what I want to put in here is going to be I1 plus I. I1 is the offset into this large array. Similarly, J1 is going to be the offset, the column offset into the A array. So this is the row offset where that block is starting, and this is the column offset for where that block is starting. Now what? I've gone through, copied all those elements, and then I can just go through or go ahead and return that B array. So this is going to extract that subarray out of the larger A array and put it into B, which is then returned back to the caller. All right, let's try something like this for this next one. Now note in this case, S here is coming in and it has a certain size. So let's create a B array that's in fact the same size as the A array. So I'm going to just say this is A dot length and A sub 0 dot length. So this is the number of rows. This is the number of columns in row 0. Because this is assumed to be rectangular, that's the number of columns in every row. Then I can loop over this B array and figure out what I'm doing. Well, what do I want to do? I want to copy everything out of A into this B array. Well, hey, look at that. All this code that I did here, maybe I could just do something like this. I could just say clone the A array. That is, let's just make a copy of this A array and I won't get rid of those for now. I'll just make a clone of this A array and put it into B. And so, I'm sort of assuming that this S array is much smaller than this A, so there's probably a little bit more efficient ways of doing this, but let's just do this for now. So we'll just start with A, but it's only where S is that I'm going to make this copy. So just like before, I want to think about this from the perspective of B. Well, where is this starting from? It's starting at N, and it's starting at M. That's going to be my upper left-hand corner. So I want to loop over every element of S. So let's change these B's here. So this is looping over every row of S, every column of S, and then in this output, what I'd like to do is copy from some S position. Well, just like we did with this subarray, what I'd like to do is think about this as an offset. Well, what's my row offset? Well, the row offset is going to be this N. The column offset is going to be M. And then I just need to go from there. So there we go. Now, after we've made all those copies, we can just return that B array. So now we've replaced the cells in A with the cells in B in these particular elements. All right, let's see if that works. Okay, so I get a null pointer exception. There seems to be some issue here. Let's see. Maybe it's this A array that's not actually coming in correctly. Maybe it's this B array that's not being initialized correctly. Seems like that B array should be initialized correctly. Let's actually just print out A at this particular point. Let's see if it actually tells us that it's null. Aha, it is null. So maybe I'm going to use it later on in this code, and I'm not going to worry about it right now. So we could guard against this just by saying if A is equal to null, I could actually return null. It doesn't make any sense to copy into an array that doesn't exist. All right, so, well, we're still getting this array out of bounds exception error in replace. So maybe we should do the same kind of business there. Just decide if A is null or S is null. We can return the value null. All right, well, we still get some kind of weird array index out of bounds exception error. Maybe we have M and N switched here. This seems like N is kind of in X position, which is kind of corresponding to columns. So let's just switch this M and N here, see what happens. That didn't address the issue with this array out of bounds exception error. So I think we need to look at that in more detail. But let's see. So B is a clone of A. So if I print out whatever B is, and I print out whatever A is, they should look identical to one another. So let's just check that out. And while I'm at it, why not print out S, because that's what I want to paste in there. maybe I'll just put a print statement in here that we're in this replace function, just so that we can figure out where in the code we are. I'll just put a couple exclamation marks to differentiate that between anything else that we might have done. Okay, so here we go. Let's track down this error. Part of the fun of programming sometimes is tracking down these errors. There's a little logic problem, and we have to figure out, well, this is what we get out, this is what my code says, why don't they match? I don't know. Let's dig through it and find out. So note that the first thing I do is print, after printing out this replace, is print out A, then print out B. So here's my A, here's my B. Note that in this particular case, both A and B are identical. They're 5 by 5 arrays. That sounds reasonable. And what I'd like to do is paste this in here, starting at N and M. Well, I don't know what these N and M values are, so maybe I should also print out what those values are. So I'll print out N, followed by a space, followed by the value of M. Maybe I'll put a couple spaces in there. Let's repeat this code. So here I've replaced 2, 2. So I'd like to start out row 2, column 2. So in fact, it didn't really matter if these were M and N were switched in this case, because they're both the same. So what's happening here? So I start I being 0, I is less than s dot length. So that's the number of rows of s. J is 0, j is less than s sub I dot length. That's the number of elements in the ith row, incrementing by 1. And then the ijth element, so so really I want to paste into B starting at this NM offset. So I think we really want to switch these so that this isn't an offset into S, it's really an offset into B, the output array where this stuff needs to go. All right, let's see if that resolves the problem. Aha, it did. So note that replace 2, 2. I have this as my input A. This is my copy of that. This is the S that I want to put in. And I said I'm starting this at 2, 2. So this 1 should go at index 2, 2. Well, that 2, 2 is right here, because this is row 0, row 1, row 2, column 0, column 1, column 2. So what I see here, this 1, 2, 3, 4, 5, 6, 7, 8, 9, that's the S array that I copied into here. Whew. Well, that was a little bit more complicated than we had anticipated, but that's okay. We did it, and now we're good to go on to the next little function. Let's see, we have row sum, we have column sum, we have diagonal sum, diagonal 2 sum. So let's work on these diagonal sums first. Those are going to be easier because they are just returning an integer. There was a question in the original code when I was discussing this, but they should just return an integer. Well, it's an array. It really should say here the value. It's not an array, it's really just a single value. That's the sum of these diagonals. So this is the northeast southwest, and this is the northwest southeast. So I think this northwest southeast is easier to do, because in that particular case we're going to have the 0, 0 element, the 1, 1 element, the 2, 2 element, and so on. So let's start by saying I'm going to have some sum that starts out at 0. Then I'm going to have a loop, and I want to loop over all the diagonals. Now I'm assuming this array is square, But well, maybe not. We don't necessarily have to assume that it's square. But let's loop over every row in this image and say for the ith row, what is the column where that element, that diagonal element appears? Well, at ith row, so note that this is going to include the elements like 0, 0, 0, 1. So this is going to be a sub 0, 0 plus a sub 1, 1 plus things of that nature. So note that if I know the row, I also know the column. It's the same thing. So in here, I can just, in my loop, I can just say sum plus equals a sub I sub I. That's going to be that diagonal element, and at the end, I can just return that value of sum. Well, that's good. That was straightforward. Now, in this case, this diagonal one sum, it's the diagonal going in the other direction. So let's actually put in a comment here and figure out what that is. So when I is 0, I want to do not the first column, but the last column. The last column is a sub 0 dot length minus 1. And then when this is 1, when I'm doing row 1, this should be this length minus 2. And the next one, let's see if we can figure out that next one. The next one is going to be a sub 2, the second row, but it's going to be whatever the column, maximum column is, minus 3 in this case. So I sense a pattern here, and part of computer science, part of mathematics, is recognizing patterns when you see them, and part of it is identifying the pattern that we see here. Note that as I move from left to right, the row index increases by 1, the column increase, or the column decreases by 1. So in fact, let me just change this to this being minus 0. This is length minus 1 minus 1, and this is minus 1 minus 2. So in general, what I have here, note, is that I'm going to have sum is equal to a bunch of stuff plus a sub I. And then the question is, well, what do I have here? This a sub I, I'm going to put in here, the second dimension is going to be a sub 0 dot length minus 1 minus I in this case. All right, so that's really what I need to put down here. For the ith row, this is going to be the column that I'm going to choose from. Wow. Okay, well, there's my diagonal sum. So let's just try and run this and see what happens. So I get a null pointer exception. That's fine and dandy. We can figure out what's happening with that. So I'm getting a null pointer exception on this particular line. Let's go back and see where this diagonal sum code was called from. So I think this code really should be diagonal sum of A there. All right. So we have subarray. For some reason that's not, not printing out anything. But we have row sum, which is 0, column sum, which is 0, which is fine. But these diagonal sums, both are 15 in this case. So let's see if it's working on this A array, which is right here. So let's see, if I add 1 plus 5 plus 9, that's 15. 3 and 7 is 10, plus 5 is 15. So these diagonals both add up to 15 in this case. So I'm pretty content with that. And also I'm noting that 20 minutes have gone by, so we're going to stop here for now. And then we'll pick back up where we've left off with our next video.